Trig is so cool and so useful, particularly basic trig, sine, cosine, tangent. It used to be one of my favorite things to teach whenever I taught geometry, or I've had math 2 a little bit before, but it's been a long time since I had either one of those. One of my favorite things to teach, because at the basic level, it is pretty simple, and I can usually get students to understand it pretty well. Okay, so what trig is that long ago mathematicians discovered that if you have a right triangle here, and you know this angle, or any one of the other two angles, then what they realized is if this angle right here was 30 degrees, then this opposite side over the adjacent side always equaled the same thing, whether it was a teeny tiny triangle or a great big huge triangle. The dividing those two always gave you the same thing if you had the same angle there. If you had an angle of 50 degrees, it was a different number, but you always got that same thing if you did opposite over adjacent. So what these trig, they're called ratios, these trig ratios are telling us that the sine, or the opposite over the hypotenuse, is always the same if you know the angle is the same. So you can basically like set up proportions for that to solve. So that's like essentially what is happening here. So the first thing you will have to do to use basic trig, first of all, basic trig is only applicable if you have a right angle. If you do not have a right triangle, you cannot use trig. You cannot use basic trig. You're going to have to use law of sines and cosines, which we're going to learn next week. But if you have a right triangle, you're going to look at which the right angle should be marked for you, and then you're going to have another angle, or you're going to be looking for another angle. All right, there'll be another angle that you're concerned with. So you need to know which side is your opposite, your adjacent, and your hypotenuse. Hypotenuse is always across from the right angle. Okay, it's always your longest side, and it's always across from the right angle. Opposite and adjacent depend on which angle you're given. So like in this particular case, I have been given this angle down here in the bottom. So the opposite angle is the opposite side is the side across from that. The adjacent is the side beside of it that touches that angle but is not the hypotenuse, right? Because the hypotenuse is also adjacent, but we know its most important name is that it's the hypotenuse because it's across from that right angle. So our trig functions are sine of theta equals opposite over hypotenuse our cosine of theta is adjacent over hypotenuse and tangent of theta is going to be opposite over adjacent. And so those ratios are always true when we look at how we can use them to solve triangles. 1 through 4, you do not have to use trig. 1 through 4 are ones you can use Pythagorean theorem. A squared plus b squared equals c squared. You guys remember doing a squared plus b squared equals c squared? 1 through 4, you don't have to use trig. So I'm going to skip down to number 5, where we start to get to problems where we have to use trig. So unfortunately, I can't pull up that worksheet because it's only in a PDF and it won't let me write on it. So I'm going to have to draw it here. I guess I could have screenshotted it if I'd done that ahead of time. Okay, but this is what I will call good enough. So you always want to think about the extra angle that you know. So that extra angle that I know is the 32. And I know I have this angle here, which is my right angle. Technically, we could find that third angle if we need it, because what would we have to do? Yeah, 32 plus 90 and subtract that from 180, right? Because your interior angles of your triangle have to add up to 180 degrees. So if you needed to find this angle for some reason, you could, but there's no advantage to finding it here, okay? So if I look at 10, I got to decide, is that opposite, adjacent, or hypotenuse? It is our opposite side. It's across from the angle of reference that we have here. So this is my opposite side. And then the other side that I care about is this X right here. Is that opposite, adjacent, or hypotenuse? That is hypotenuse. Right? So, if I have opposite and hypotenuse, which one of these trig functions do I want to use? I need to use sine. You have to have those memorized. You can SOHCAHTOA. Some old hippie caught a high tripping on acid. My husband, who had the same geometry teacher as me, so I don't know where he learned this, he says Oscar has a hairy old body part of your choice, arm there. So, arm, definitely arm. So whatever colorful acronym you want to use to help you remember that, these three right here have to be memorized. You've got to know them. To be able to use regular trig. So sine is opposite and hypotenuse. So we're going to do sine, and that theta right there, sometimes they'll use x's instead. Theta is just a variable. It's a variable we typically use for angles, though. They like to use that variable for angles. So that has to be an angle. It is our 32-degree angle. Don't use the 90. It has to be the other one. And then opposite side is 10, so that goes on top. Hypotenuse is x, so it goes on the bottom. And so I told you guys a minute ago to make sure that your calculator was in degree mode, because if you reset your calculator, it's going to go in radian mode. So if you hit the mode button is right beside the blue key here, and on that third line right there, you need degree to be highlighted. If it's not, if it looks like this, just go over, hit enter so that degree is highlighted. Because since you're doing these problems in degrees, if you type them into your calculator and you're not in degree mode, it's going to give you the wrong answer on everything. So make sure you're in degree mode if your problem has degrees. We will learn radians as well, but for what we're doing in Unit 5, we'll be using degrees for everything. In Unit 6, we will learn the unit circle and do radians, but right now, everything's going to be degrees. So, yes, I will have to give you your calculator on all trig stuff, because sine of 32, your calculator has it stored there. Uh-oh, why did it do that? Your calculator has it stored that sine of 32 equals this ratio. It equals this number right here. So, like, when you see sine of 32, it looks like it's a variable or like something weird, but it's really just 0.529919264.2. Before you had advanced calculators, like if you went back to like my parents' day of doing trig, whenever they just had really basic calculators, they would have had to have a table with the values for all their sine angles, right? So they would have a table that had sine of 32. They'd go look up sine of 32 and put that number there. But your calculator will do it for you, so you'll have to have your calculator on this stuff. This is one of the few times when I had Woo many years ago. Woo was an exchange student from South Korea. He never used his calculator. He told us that in Korea the calculator was cheating. They didn't let him use their calculator or anything. But This is the only thing I'd be like, well, you're going to have to use your calculator. You cannot do this without a calculator. Go get it. So he had to adjust there because his Korean ways, he was not going to use a calculator unless you made him. There was no other way, which I thought was cool. All right, so you need to solve this equation for x. X is in the denominator. Can you solve for anything that's in the denominator? No. You cannot. So you are going to multiply both sides by x, which is going to give you x sine of 32 degrees equals 10. Remember, sine of 32 degrees is just a decimal. You can go ahead and plug in that decimal if you want, but I don't. So you're dividing both sides by sine of 32. As you do several of these, you'll notice you might like skip actually writing all this out, but I'm going to right now so y'all follow me. All right. So x is going to be 10 divided by sine of 32, which is, calculator open twice there, 10 divided by sine of 32 is 18.871. I typically like to round to 3 decimal places on these. The answer key for this worksheet, some of them are going to round to the nearest tenth. Some will even round to the nearest like whole number degree, which I don't love, but I couldn't fix it where it would do 3 decimal places. So, but you can check. If yours matches what they have rounded, then you should be fine there. But I usually, on quizzes and tests, I'm going to have you keep probably 3 decimal places at least. There. So the length of that side is 18.871. Always ask yourself if it makes sense. If you got 273 for that answer, would that make sense for that? It would be crazy, right? If you got 8.213, would that be right? How would you know that couldn't be right? Right, because this is the hypotenuse. It needs to be longer than 10 for sure, right? Always, whenever you do these problems, always ask yourself if it makes sense at the end too, because you can catch some of your mistakes if you've got a number that's kind of crazy. Okay, we okay here? All right, let's do one more. Let's do number 8 in that section. So we got 8. We got, and once again, if you already know how to do this and will work ahead of me, that's fine. You will not hurt my feelings today. Okay. All right, so this time we're looking at our extra angle right here is 22. So x, is that opposite, adjacent, or hypotenuse? Hypotenuse. It is across from our right angle. It's our longest side, so we know it's hypotenuse. It looks adjacent-y, but it is the hypotenuse because it's across from the right angle. 19, is that opposite, adjacent, or hypotenuse? That is adjacent. Okay? So adjacent and hypotenuse, which one should I use? Cosine. So cosine of 22 degrees, always put your angle there, is going to equal adjacent, which is 19, over hypotenuse, which is x. I really should have done one where the x was on the top. It's easier to solve if the x is on the top. Then you just have to multiply. So you're solving for that x. You got to multiply by the x to get it out of the denominator. Then you're going to divide by that cosine 22. So your x is going to be 19 over cosine 22, which if we type into the calculator, is going to give us 20.492. There. So that's your length of your side. It's going to be 20.5 whenever they look at when you look at the answer because they round it to 10. Okay, questions? You guys remember, is it coming back some? You remember doing this before? Yes. Let's do 6. Well, 6. Yeah, we'll do 6. 7 or 7. Doesn't matter. I said 6. Let's do 6. Okay, so we're looking at this angle right here. That's our focus angle there. So X, is that opposite, adjacent, or hypotenuse? It is opposite. It is across from the angle that you're looking at. And then 16, is that opposite, adjacent, or hypotenuse? It is not the adjacent side. Adjacent is going to be over here. This one looks kind of adjacent because it does touch the angle, but it's across from that right angle. It's your longest side, so this is the hypotenuse. Whatever's across from that right angle, that's going to be your hypotenuse. So with opposite and hypotenuse, what trig function do I need to use? Sine. So I will do sine of your angle goes here, and that is going to equal opposite, which is x, over hypotenuse, which is 16. So they're actually a little bit easier to solve if your variable is in the top of that fraction, because this is x divided by 16. The only thing we've got to do to get rid of that 16 is just multiply both sides by 16. So x is going to be 16 times sine 36, which we are going to do by typing that into the calculator. And we should get 9.405. Or it's going to be around to 9.4 on the answer key. Yeah, we're getting ready to. All right, so those problems are ones where sides are missing. Their other type of problem you're going to see are like 10 through 14, where your angles are missing. So if you want to make yourself a little note there, if you are trying to find an angle, you must use inverse trig. It's not as difficult as that sounds. You're going to set it up more or less the same way, but to solve, you're going to have to use inverse trig. So let's just do number 10. Actually, yeah, let's do number 10. Oh, I gave you all 3 sides. I should have given you some that don't give you all 3 sides. So, you don't have to have all 3 sides. I just did here. I think it was an option. I should have done some where it did give you all 3 sides and some where it did not. 14, 50, and 48. And then this angle right here is question mark. We don't know what it is. Okay, so as far as setup goes for these problems, you're setting it up basically like we did the other problems. The difference is what we're missing is the angle. So a lot of these problems, a lot of times, they will only give you 2 sides. I think it was an option on the program I used to make these worksheets. Like I could have given you all 3 sides or just given you 2 sides. I should have mixed it up where I did a little bit of both, but I obviously did not. So because this gives you all 3 sides, it allows you to pick your favorite trig function and use it. You could use any of them, but a lot of times there's only 2 sides, so you can't do that. So the first thing you need to do always when you're doing trig is decide what's opposite, adjacent, and hypotenuse, right? So hypotenuse is right here it's 50. It's across from that right angle. The angle that you're looking at here is right up here. So 48, that's adjacent. It actually is like the side that touches the angle, but it's not the hypotenuse. And then 14 is your opposite side. Now, because I have given you all three of the sides, you could use sine, cosine, or tangent. It does not matter which one you pick. You can just pick your favorite one. We have not used tangent yet, so I think I will just use tangent just to use tangent, right? But you could use sine, cosine, or tangent. If we use tangent, we'll have tangent. I'm going to call that question mark right there, I'm going to call it theta. Or you can use an X or an A or a Z, whatever you want to use. Just put a variable there for it. You could use the question mark if you want. So tangent is opposite over adjacent. So that would be 14 over 48. And I only picked tangent just because I wanted to, right? You could do it with sine or cosine. I'll show you in a second how you get the same answer. So you're trying to solve for that theta. You're trying to get that angle by itself, which means what do you have to get rid of? The tangent. So you cannot divide by tangent. If you try it, if I did 14 over 48 and tried to divide by tangent, you're going to get an error because you can't do that, right? Tangent is an operation. It's not a number for you to divide by. Like if that was a 7, yeah, we could divide by 7. We can't divide by tangent. To get rid of tangent, you have to use inverse tangent. Okay? And on your calculator, if you will look above tangent right here, you see in blue tangent with a little -1 power. That is our notation for inverse tangent. So what will happen here is inverse tangent of tangent, those cancel each other out. Kind of like e's and natural logs canceling each other out. Inverse tangent and tangent cancel each other out. We're just left with theta over here. And so we need to be doing inverse tangent of 14 over 48. And so we're just going to type that into our calculator. Inverse tangent of 14 over 48. Oops. You're going to hit the blue button and the tangent button. And we get 16.260. So our angle is 16.260 degrees. They're going to have 16. They're actually going to have 16. They run the nearest degree. I really don't like that. I don't like rounding to the nearest degree. Alright, so, and that looks reasonable because it's a pretty skinny angle. Don't assume that it's drawn to scale, but it's usually drawn to scale. Okay, let's do another one of those. It does not matter at all which one we do, but let's do 13. So for 13, I've got 33, 55, and 44. And the angle that we're looking for is this one right down here. Alright, I'm going to do this to you guys right now just as we're going over these. Let's pretend that we don't know that this is 44. We're just pretending that we don't know it's 44. And that is just because I forgot to put any on the worksheet where you are actually missing 44. So let's pretend that we don't know that that side is 44. If we don't know that, then we need to think about the sides we do know. 55, is that opposite, adjacent, or hypotenuse? Hypotenuse. 33, is that opposite, adjacent, or hypotenuse? It is adjacent. Okay? So if I did not know 44 there, what trig function would I have to use? I would have to use cosine. So I'd have to say cosine of theta equals 33 over 55. Now, because that's not really the case, it would be fine if you set this up and said sine of theta is 44 over 55, and it would be okay if you said tangent of theta is 44 over 33. Those are also okay, but we're just pretending like we don't know what that side is. So if I'm trying to solve this for that theta right there, what do I have to do? How do I get rid of the cosine that's there with it? Inverse cosine. So I will be doing inverse cosine of both sides, which means over here, oh, good gracious. Over here, the cosines just cancel and I get a theta. Over here, I'm going to be doing cosine inverse of 33 over 55. And so if I do that in my calculator, cosine inverse is just second cosine 33 over 55. And I'm going to get 53.130. Degrees. Answer key is going to say that's 53. So anytime the angle's what's missing, you set it up normally, but to solve, you're going to have to use inverse trig. All right, and let's do number 16 together. And put it all together here. And I'm pretty sure the way they have marked this with the 10, that 10 is just this section right here. It would be better if they had put like a line there showing you it was only that segment, but I'm pretty sure that's what we've got. Okay, so these are going to be multi-step problems. Because the question asks for, us to find the area of the triangle. What's our formula for area of a triangle? 1/2 base times height, right? So in this triangle, we could let this be our base. This side right here is our height. Do we know either one of them? No. We do not. Could we find either one of them? Which one could we find first? We can find heights first. So if we are just looking at, and I failed to draw, no I did. So we're looking at this right triangle right here. We're just looking at this right hand side of the right triangle. This is a right triangle, so we can use trig. And we know one of the sides. So for this, H is the side I want to know right here. That's my opposite side. And 10, what side is that? Opposite, adjacent, hypotenuse. Adjacent. So opposite and adjacent, which trig function should I use? Tangent. So I'm going to say tangent of 27 equals opposite, which is H, over adjacent, which is 10. Okay? I'm just going to multiply both sides by 10. So 10 tangent 27, I get 5.095 is my height. Now, let me tell you this. This worksheet says round intermediate values to the nearest tenth. Use the rounded values to calculate the next value. Round your final answer to the nearest tenth. I do not like that. It is. I do not like that they tell you to do that, because it is going to be more accurate if we keep the entire decimal here. So, I'm going to ignore their instructions and just know that my answer might be off by a tenth or something at the end, because I don't like their instructions. But if you use their instructions, you would do 5.1 here to find the next step. I don't like that. In fact, what I would tell you to do, have you guys stored values on the calculator before? Okay, so on the calculator, we can store this like long decimal so that whenever we use it again, it'll automatically have that for us. Sometimes you can do it just with the answer key, but sometimes it may not work out for you. If we know this is H, if you hit this button right here above your own button, it says STO. It's going to say answer and have a little arrow there. And then, you guys know how to make letters, right? Because you've written a message on your calculator to whoever's coming up next. A nice message, of course. For letters, you're going to do alpha. I'm going to call it H since my variable here is H. But you could store it as anything. Warning, I think on most of these it's fine, but don't store it as X or Y, just because that can, depending on how new your calculator is, it may interfere with your graphing. So anything except for X and Y is okay, though. So I'm going to call this H right here. So now anytime I type H, it actually is that value. So it's stored. And I can just type an H instead of having to type in that whole number. There is a way to delete it out completely that I can't remember right, like to clear it out. If you just wanted it to be a different number, you could just store a new number on top of it. So for the next problem, if my H is 15, I could just hit store H with the 15 and it would replace it. I just would warn you, don't put it for X or Y, because depending on if your calculator is older, it may interfere with graphing and it could be an issue. But otherwise, the other letters, it's going to stay in there until it's replaced, but it's not going to be an issue because you can just replace it there. Okay, so that's stored, because what we're going to need to do now is we need to know, we need to look at the other triangle here. Since we have now found this is 5.095, we need to find this side right here, which I'm going to call X. We haven't used the X yet. We need to find this side, this little piece right here. And if we find that, we can have our base, right? We found our height, we need our base. So if I'm looking at this green triangle, now 44 degrees is my angle that I have. Is H still the opposite side in this triangle? It is. X, is that opposite, adjacent, or hypotenuse? Adjacent. So we're going to use tangent again. We'll say tangent of 44 equals opposite, which is 5.095, but I'm going to use that stored value in my calculator, over adjacent, which is X. And I'm going to solve for that X, which I cannot do with it in the denominator, so I'm going to multiply both sides by X to get it out of the denominator. So now I've got X tangent 44 equals 5.095. I'm going to divide by tangent 44. Oops. So X is going to equal, let's see, in your calculator, it worked out on this particular one where you could just do divided by tangent 44 and you would have gotten the answer. Or if we want to use our fancy new trick, you could tell it alpha H divided by tangent of 44, and you should get 5.276 there. So that's just this little piece. What would the base of? We'd add the 10 to it, so we'd have 15.276. If you really want to be precise, add 10 to it here. You could even store that as your B if you really want to. Yeah. Yeah, you can have everything stored. Yeah. And so now, if I want area, I can do 1/2 times B times H. I wonder if I might need a multiplication between that. I don't know if it recognizes it like that. 1/2 base times height, and it'll give you your answer. So that would be if we had rounded nothing. It may actually be a little off from the answer key. Yeah, because 30? 30, okay, 39. Yeah, that still rounds the nearest. It's close enough. But this is more accurate than what the answer key is giving you. I just do not like their instructions there. So our area was 1/2 base times height, and that gave us 38.918. There. Okay, questions? You guys still have a few minutes, so if you're not finished with the worksheet, maybe try to do a couple more. But that's all we're going to do together. Is it coming back? Do you remember